In this lesson, we're going to look at solving compound inequalities with what I refer to as special solutions. So we're just going to look at some examples eventually, but to get us going, I'm just going to take a look at graphing the solutions to these two inequalities. So remember, the first thing to do is recognize that in this first one, the blue one, I have an and inequality because of the way that it's written. So I'm going to rewrite it in and format. Remember, we'd have the two inequalities that we have to pull apart. 3 is less than or equal to x, and x is less than 9. Those are the two pieces that we're going to have to graph onto this number line. So if I graph x, I'm going to look at this one here. X is greater than or equal to 3 because I'm reading it backwards. So I'd start at my 3, I would shade it in, and then I'd have to graph everything going that direction. But then we also have x is less than 9. So then I come over here to 9, everything that's less than it, that's everything going this way. So you'd see that we have this overlap in here, remember? And our solution set then is everything in between, because it's an and statement, so it has to satisfy both. And the numbers from 3 to 9, where we include 3 but not 9, all those numbers in between are going to satisfy both inequalities, the one on the left and the one on the right. Now, when we come over here to this green one, this is x is greater than 6, union x is less than 4. Remember, this is just a fancy way of saying the word or. So now I graph this, well, x is greater than 6. Start here, open dot, greater than, there. And then my second one, x is less than 4, I go to 4, and again, open dot, go this way. Now, being this is an or statement, it doesn't matter. I could have solutions from over here or over here, so the graph looks like this. Now I'm going to come and I'm going to graph these two. These are a little different, and I'm going to start out with x is greater than 1. So if I graph that part, I'm going to start at 1, and then everything's going this way. But then or x is less than 9. So I start at 9, and I go like this. Now you think back and go, well, that looks an awful lot like this one, right? But remember, this was an and statement. And the one that we're working on now is an or statement. So what does that tell us? Well, since it's an or statement, we don't have to satisfy both pieces. We only have to satisfy one of those inequalities. So when I really look at this, maybe I should just bring this up a little bit and bring this one down a little bit. So if I think about it, this one here is going to continue and keep going this direction. This one is going to continue and go that direction. So when everything's all said and done, when I look at the solutions to this, my entire graph is covered, because if I put them back together, that one's here going this way, everything going to the call left. This one, though, bring that back down, and this one back down, and now I have everything going to the right. So I've covered my entire number line when I've graphed an or statement that looks like this. So when I look at it, really the solution to this one is all real numbers, and if I use my abbreviation, that's the all real numbers. Now in this one, we look at it and see that we have an and statement. So if I break it apart into its two parts, I'm going to have 7 is less than or equal to x, and x is less than 2. Okay? So I'm going to start with the one here on the left. I have x, I'm reading backwards, x is greater than or equal to 7. So I'm going to come here. X is greater than or equal to 7. Now it's going to look like this. And then I have x is less than 2 for my second one. Well, 2 less than this way. Now, keep in mind, though, this was an and statement. So in order to satisfy an and statement, both parts have to be true. In other words, we have to find a number that's greater than 7 and a number that's less than 2. But there are no numbers that satisfy that. So when we look at this one, there are no real solutions, or there are no solutions. because we're working on the number line, so I said real. So there's no real numbers that are solutions to that one. And these are the two important pieces that we need to recognize when we're solving our compound inequalities. Sometimes these kind of goofy situations happen. So we'll start with this one. Now I have an or statement that I want to solve. So remember, an or statement, we just have to solve the two parts. I'm going to start with this piece on the left, the red part, and I'm going to solve that inequality. Now, what I would do is I like to have my variables on the left side, so I'm going to subtract 6x from both sides. And since my x's are all going to be on the left, I need my constants on the right. I'm going to add the 5 to both sides at the same time. And now I'm left with negative 4x is less than 12. And then I continue on, and I'm going to divide both sides by negative 4. Now remember, when we divide by a negative, we have to flip the sign, and we have x is greater than negative 3. Now I'm going to go to my next one. This one, I'm just going to subtract the 1 from both sides. I have my x's, all of my x's are already here, less than or equal to 10. And then I'm going to divide both sides by 4. And when I do that, I end up with x is, why did I say 4? I don't want to divide by 4. That wouldn't help us, would it? How about we try dividing by 5? And I'm going to end up with x is less than or equal to 2. And you think, well, just put the or between them and we're good to go. Here's what I need you to think about. If we look at this on the number line real quick, I have x is greater than negative 3. So if I look at negative 3 being here, I would have a situation looking like this. And then if I go to my second one, now I have x is less than or equal to 2. Well, if negative 3 is there, 2 is going to be over here somewhere. And it's going to look like that. Now remember, this was an or statement right there in the middle. Okay? So since we have an or statement, and this part's going to tell us we need all these numbers going to the left, this part tells me I want all the numbers going to the right, I am going to have that entire number line covered. Now, some of you think, well, but the negative 3 has an open dot. But remember, this is going to go through it and take care of the 3 is going to be a solution. So when it's all said and done, the solutions to this compound inequality would be all real numbers. Or if you want to write out all real numbers, that's fine as well. Now I have another example of a disjunction because it has the word or in it. And again, we're going to solve our two little inequalities. So I'm going to start this one by dividing both sides by 3, and we've just figured out that n is greater than or equal to 6. I'll go through and solve the other one. So in this case, I'm going to subtract the 12n from both sides, because I like to have my variables on the left, which means I'm also going to have to get my constants to the right. And I end up with negative 2n on the left side. I end up with 14 on the right side. Since I'm just adding and subtracting, my sign stays as is. And now I'm going to divide both sides by negative 2. But remember, when we multiply or divide by a negative, we have to flip the sign to look like this. So again, we have our two inequalities. This was an or statement. Some of us would just think, well, I'm done. But again, I'm going to ask you to think about what this looks like on the number line. This one's a little different. So if I start with my one on the left here, n is greater than or equal to 6, put my 6 here, I'd have a closed dot, and then it would look like this. But if we go to our second one, where it says n is greater than negative 7, well, then I'd have to come over here. Negative 7 is going to be out here somewhere. I'd have an open dot. Greater than, that's all these numbers here. Well, when we look at this, what I have graphed here in the pink, that's just going to keep going this way, and it's going to totally cover up everything that I had in the green. I think of it that way. So really, we don't have to write two inequalities as our solution, because every number that's greater than negative 7, that's all these, is also going to be numbers that are greater than 6, because that's how it works. Numbers greater than -7 will always be, are also going to, they will incorporate all the numbers that are greater than 6. So when we're done, our solution, all we have to write is x is greater than -7. So a lot of times when we think about compound inequalities, we always think there's going to be those two parts. Well, in this case, there's only the one. X is greater than -7. And then I have my last one here, and I look at this one and I see that I have this kind of smushed together compound inequality because I have a piece here, a piece here, a piece here, with my inequality symbols here. So remember, that's telling us that we have the and compound inequality. So I just have to pull it apart into its two pieces. So we're going to have 2r plus 22 less than or equal to the 6r minus 10. And then the other one's going to be 6r minus 10 is less than 2r minus 9. So we go through and we solve both of our inequalities. I'm going to subtract 6r from both sides to get all my variables to the left, subtract the 22 from both sides to get all my constants to the right. And now I'm left with -4r less than or equal to -32. We divide both sides by -4. We end up with r. Now remember, we have to flip our sign here. Greater than or equal to 8. And now I'll solve the other inequality. I'm going to add 10 to both sides. And I'm also going to subtract 2r from both sides. So now I have 4r less than, we end up with 1. And now, if we divide both sides by 4, well, we end up with a fraction. And that's okay, because we can work with fractions. There. And remember that this was and. But again, don't just stop there. Let's try to think about what does this look like on the graph, because I think that helps us come up with our solution to this one. So if I graph this, r is greater than or equal to 8. Well, 8 would be, say, here. So then I'd have all of these numbers. But then if we go to 1/4, 1/4 is smaller than 1/8. So on my number line, 1/4 might be right here. But now I need r being less than 1/4. So open dot, and then it's going to go this way. Keep in mind, though, we had the and compound inequality. So that's telling us that our solutions have to satisfy both inequalities. Well, are there numbers that are greater than or equal to 8? And at the same time, less than 1/4? No, there are no solutions to that. So in this case, to this compound inequality, oops, wrote that wrong, there are no solutions. And since we were working on the number line, I probably could have said there are no real solutions. So keep that in mind. Sometimes inequalities have that solution like x is greater than 5. Sometimes we get the compound inequalities where it looks like there's two of them crammed together in our and situations, and sometimes we have those ors where we have multiple things where x is less than 1, and, or I shouldn't say and, or x is greater than 2. But sometimes we get these situations where there's no solutions, or if we come back here, we had a compound inequality to start, but in the end it was just a single inequality as the solution. And sometimes we get the times like this one where it's everything because our whole number line is covered with solutions. So that's going to end my lesson on compound inequalities, or solving them with those what I refer to as the special solutions.